Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is maximum length of a concatenated string with unique characters. So you are given an array of strings. A string is formed by concatenation of subsequence of array that has unique characters. So those of you who are not familiar with what a subsequence is, subsequence is an array that can be derived from another array by deleting some or no elements without changing the order. So for example, let's take this input. So if you want to form subarrays of this particular subsequences of this particular array, so what you can do is you can pick 0th and the second index, okay, but you cannot pick second and the 0th index. So it is a valid subsequence representing these two. But this one is not a valid subsequence since the relative order that was there in set is not same as that in the subsequence. Okay, so u is coming before un, so that's not a correct subsequence, it is a correct subsequence. Okay, so that's what a subsequence is, by deleting some or zero elements without changing the order. So what you have to do is you have to return the maximum possible length of s that can be formed by concatenation of subsequences of this particular array. So for example, if this is the input given to you, these are the valid subsequences that can be formed. Okay, and among these subsequences, this subsequence concatenation, these are subsequence concatenations, and among these subsequence concatenations, this one is the subsequence concatenation that is having minimum length. Okay, so not minimum, maximum length. Okay, and this one is also having maximum length, but that doesn't matter since we are required only to return the maximum length possible after concatenation. Okay, and let's see what are the constraints. So the length of the array is of order 16 and the elements are only lower English letters, and the element size is 26 at max. So let's see how we will be solving this particular problem. First of all, we'll try to apply a brute force approach, and we'll be seeing whether this brute force approach is sufficient enough to solve this particular problem. Okay, so brute force approach. What will be the brute force approach? It will be that we will be generating all possible subsequences. Okay, and after generating all possible subsequences, what we will be doing? We will be checking for the valid ones, those having only unique characters. Let's say a subsequence generated was un and ue. This is a subsequence that was generated, and if we combine all the characters in this particular subsequence, then you will be seeing that u is repeated. So this is not a valid concatenation, or say a valid string to be considered, so we will ignore that. Let's say another subsequence that was generated was un and iq. So you can see that after concatenating these two strings, you will be forming a string that is not having any repeating characters. So it's a valid string to be considered, and we will consider its length. Its length will be 4, so we will be taking it into account while calculating the maximum length possible. Okay. So these are the two things that you will be doing. Now we will be seeing how much time or how many number of operations that will require us to do. The size of the given array, let's call this ARR. Let's say it's n. Here we will see what is the order of n. It is 16. So every entry in this particular array is having two options. Either it will be included in the subsequence or it will not be included in the subsequence. Okay. So every entry is having two options. So you will be having these number of options, and it will be 2 raised to power n times. Okay. So, and also you will be checking how many unique characters we are having. Since we are required to check only lower English letters, that are 26 only, so we will somehow devise a way so that we will be running this loop only for 26 times. Okay. For now, let's say additional 26 times is also required for each of these cases. So this will be the number of operations that will be required in total. So order of operations will be these, and let's say let's see what 2 raised to power 16 into 26 is. Okay. So it is this number, and as you can see it is having only 7 digits, so it is definitely smaller than 10 raised to power 8. So this one is smaller than 10 raised to power 8 operations limit. Basically, if the number of operations that your program will be requiring, number of operations required by solution, approaches 10 raised to power 8 becomes equal or greater than it, then you may get a TLE and your solution will not be accepted. Since that is not the case here, we are well within the limit of this operation limit, so our solution will be getting accepted. So that this is the logic that we will be applying to solve this particular problem. First of all, we will generate all of the subsequences that are possible, then we will generate strings corresponding to those subsequences, and we'll be checking that whether those strings are having unique characters or not. If they are having unique characters only, then we will consider those strings for updating our maximum length that is possible. Okay, so let's see the implementation. So this is the implementation part. What we have done is, if let's say the size of this particular, basically for this implementation you should be knowing one concept, which is bit masking. Those of you who are new to bit masking, I will be providing link of article describing what bit masking is. So what you do in bit masking is, let's say you are having a n length array. Okay, this is a n length array, size of the array is n. Then what you will do, you will right shift bits of 1 by n times and subtract 1 from it. Okay, so these many number from 0 to this number, this will be the these will be the numbers that will be representing all of your subsequences. What I mean by this is, 0 represents, in total there are 32 bits. Okay, so these are 32 bits. Each bit is an index here. Okay, so this is 0th index, this is first index, this is second index, this is third index. Since in the constraint it was mentioned that the length will be less than equal to 16, so it is very well within the bounds of 32 bits or even 31 bits. Okay, the last one is more significant bit, so even if you want to ignore that, and you will be ignoring that also, so it is well within the bounds of our integer, 32-bit integer. So all the configurations of the subsequences possible can be represented by 32-bit integer. Okay, so that's what we are doing here. We are just generating all the possible subsequences, and each subsequences will be represented by a integer. So 0 will represent one subsequence, then 1 will represent one subsequence, 2 will represent one subsequence, and 3 will represent one subsequence. If you write the binary representation of 3, it will be 1 and 0. If you take a 3-bit binary representation, it will be the 0th bit, it will be the first bit, and it will be the second bit. So it will correspond to 2 and it will correspond to 1. 2 plus 1 is equal to 3. So the first index and the 0th index you will be taking. So I hope I am making sense to you, that corresponding to each number we will generate a binary representation, and that binary representation will be telling us which indices we will be taking in this particular array. Okay, so 0, 2 and -1, there will be indices, and it will tell us which indices we will be taking. So from 0 to 15 bits we are only worried about as of now. For all the bits that are on the right hand side, we are not worried about that. It will be taken care of by this limit. So the number that will be generated by this limit will only be having your bits set to 15th place only. Since if you right shift it 1 by 16 places, you will be having on the 16th bit you will be having one as set bit. If you subtract it, then only 15 places will be having set bits at max from 0 to this number. So I hope I am making sense, and also I will be providing a link of article describing what bit masking is. So we will be generating the subsets. So these masks subsequences, these masks will represent, or say each mask will represent one subsequence. Binary representation will represent one subsequence. Okay, now how will we be seeing that which indices are to be included? If you do a AND operation of one right shifted to the index number of times, and if you do a binary operation with binary AND operation with this particular, let's say this is the masks that you are having, it is the binary representation as of now, and you are checking for the 0th index in the array. Now if you right shift 0th index by 1 by 0 times, this was the index, then it will be something like this. Okay, this is the 0th bit, this is the first bit, this is the second bit. Now if you do AND operation of these two, you will be getting a number that is not equal to 0. Okay, since you will be getting this number and it represents 1, so it is not equal to 0. So that's indicating that this index will be present in your current subsequence. If this condition holds true. Now you will be checking whether the string that will be generated by concatenating all the strings that are present in the current subsequence is a valid one or not. So this will take care of that. We will generate a frequency array. Now this frequency array, if it was mentioned that there are only 26 lower English letters, so let's say you take relative difference of A with A, it will be 0. If you take relative difference of B with A, it will be 1, and so on. Relative difference of Z with A will be 25. So in total 0 to 25, 26 numbers are required by you. So we can very well use this 26 length frequency array. Okay, and we will be taking these relative differences of each character. And if let's say after before incrementing this particular index at frequency array, it is already greater than 1, then it will be indicating that this particular character is repeated. So you will be returning false from here. Otherwise you will be returning true, that this is a valid one, you are not having any duplicate characters. Okay, and since we have already initialized our maximum length to 0, we are not needed to check for the empty string that will be generated. So we will be checking only for the non-empty strings that will be generated by concatenation of the current subsequence. So this loop is for generating current subsequence. And string formed by concatenation of this its characters. Okay, and at last we will be returning our maximum length that is possible. So this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.